In this video, I'm going to be teaching you guys about tautologies and contradictions in discrete mathematics. So, what is a tautology? Well, a tautology is a statement, a logical statement that is always true. So, if you're thinking about a truth table, no matter what the inputs are for this logical statement, true, false, false, true, 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 doesn't matter, right? P and Q have different inputs, but no matter what these are, they will always be true. The inputs or the truth table will always output a true value for a tautology. And a contradiction is always false. So no matter what the inputs are for the contradiction, for P or Q, or just for P, a contradiction will always give you a false value. Now, there are two ways to tell whether a statement is a tautology or a contradiction. The first way is by simply using a truth table and testing out all the possible combinations, which is what I'm going to be showing you in this video. But the second way is by using something called the laws of propositional logic. Now, the reason why I'm not going to talk about it in this video is because, well, that's going to be another video, but I haven't covered this in this playlist, and also the way that my class curriculum did it is covering propositional logic after using truth tables to test this. So if you want to know maybe a glimpse of what laws of propositional logic are, it's basically just using, I guess, the algebra of discrete mathematics to manipulate an equation to just give you a some real number at the end. Okay, so like for example, 3x plus 2x. Sorry, 3x is equal to 2x plus 1. You can sort of manipulate this to give a whole value for x, right? It just simplifies the entire equation. So you can think of it as that. But let's go ahead and test out this tautology first. This one right here. It's the simplest one out of all of them. But let's go ahead and make a truth table. Okay. So if we draw a truth table like this, our only possible input is P. There's no Q here, so I'm just going to put P here. The possible values of P are true and false, correct? And we also need to write down not P, since this problem has not P in it, or inverted P. So what is the inverted version of P? Well, the inverted P is basically when you invert true, you get false. When you invert false, you get true. Okay, now let's look at this. This is the OR operator. And if any of the values on either side of the OR operator are true, then the output will be true. So let's take a look at this. Let's take a look at the first case scenario where P is true and not P is false. So we put true here and we put false here. Realize that there's one true here. Therefore, this entire statement is true in the case of this. Okay, how about false true? If we input false here and true for not P, then you get one true. Therefore, this entire statement is true when P is false and not P is true. So therefore, this guy right here is a tautology. We just proved that this is a tautology because all the outputs, no matter the input, well, in this case, there's only two possible inputs because there's only one variable, but no matter the input, the output is true. Let's go ahead and test out this statement. This is one of the statements I showed at the beginning of the video as a tautology. So if you remember that, this is the statement. And the possible inputs for P and Q are true, true, false, false, and true, false, true, false. All right, so the possible inputs for P and Q are true, 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 false, false, true, and false, false. Those are the four possible combinations of inputs for P and Q. So let's go ahead and test out P and Q first. So this is the AND operator, and the AND operator is true only when both the inputs are true. So in the case of true, true, well, we know this AND operator will give us true. But we have false values along P and Q on the rest of these inputs. Therefore, everything else will be false. All right. Now, let's go ahead and test this out. Now we have the conditional. Okay? So remember, the conditional is only false. So this conditional is only false when the left side is true and the right side is false. Okay? So let's go ahead and try that out. All right? So for a conditional, remember, since the only time when the conditional is false is when the left side is true and the right side is false, that means if the left side is false of the conditional, then, or the hypothesis, if I want to use the actual word, but if the hypothesis is false, then that means this entire statement will always be true. Okay. Now, if you don't know what conditionals do, I have a video on that. Link will be down in the description for you guys to just click. It's very easy, so you don't have to scroll through some playlist or my account or something like that. But let's go ahead and test this out. Okay, let's go ahead and look at this. P and Q right here is true, and P in this case is also true. So we look true, true. Well, true, true gives us true. Okay. Now look at P and Q. Along this entire section right here, P and Q will be false. And remember, for any conditional, if the hypothesis or the left side of your arrow is false, then the entire conditional is true. So we don't even have to check for P. These are all true. Therefore, this is a tautology. Now let's go ahead and test out the contradiction I showed at the beginning of the video. We have P, not P, and we don't have a Q. So the only possible inputs are simply just true and false. Let's go ahead and invert this true and false. Inverting it gives us false and true. Okay, and if we compare them with the AND operator, what's going to be our result? Well, if we compare true false first with the AND operator, remember for the AND operator, both the inputs need to be true. So in order to give back a true, right? So since we have a false here, this entire statement is false in the case of this first input. Okay, how about the second input? Well, since we have even one false, well, if you have even a single false for the AND operator gives you back an output of false as well. So all the possible inputs are all false for the statement. Therefore, this is a contradiction. Let's go ahead and test if this is a contradiction. So we have two variables, P, Q. So the two possible inputs are true, true, false, false, and true, false, true, false. Now how about not P and not Q? Let's go ahead and not P, all right, invert P. So we have false, false, true, true when we invert all the values of P. And if we invert all the values of Q, we get false, true, true. Okay, now I'm just going to explain why I'm showing you the entire truth table, because this thing looks gigantic. I'm just showing it so that you guys can follow. Truth tables just make things easier so you don't have to do a lot of work inside of your head. You kind of have the intermediate steps right already there, so you don't really it's less room for error basically. And also, sometimes when you have aphantasia, it's very hard for you to follow like and store things inside of your head. If you don't know what aphantasia is, it's a really weird, I'm not saying you're weird if you have aphantasia, but it's a really weird like I would say trait, okay, that you can't visualize inside of your head. You literally, people don't have an inner monologue. Some of the people don't have inner monologue, but some don't even have the inner visualization in their head. Like they can't even picture an apple in their head, and they don't have an inner voice, right? And that's completely weird. But some people have an inner voice, but they don't have the picture, and some people have the picture, but not the inner voice, okay? I guess there's a spectrum for it, but it's crazy. I had a coworker that had it, and I was so fascinated. I was like, that's just so crazy. But P or Q, right? We know the inputs are P or Q, so let's compare P and Q. True, true, right? True, true for the OR operator is true. True, false for the OR operator is true. False, true for the OR operator is true, and false, false for the OR operator is false. Okay, let's look at the final statement. Okay, this is the final statement I had at the beginning of the video. Let's see if this is a contradiction. So let's compare P or Q with and not P and not Q. All right. Now here's the thing about these and operators. If any of these values are false, okay, then automatically this entire statement becomes false. All right. So let's look at P or Q. P or Q in this case is true. Okay, so we have true so far, but not P and not Q are both false. So if we have a false here, we have true and false, this entire thing just simply becomes false on the first possible case of inputs. And remember, if we have any falses along this entire row, right, then this entire statement becomes false. And I'll do this step by step, but as you can already tell, this one would be false, right? Let's go ahead and test out the inputs for this. True for P or Q, and for not P. So not P is also, actually it's false in this case, so we already have a false, and not Q in this case is true. But since there's even a single case of a false here, this entire thing has become false. test out the next case. We have a true, and we have not P, which is true in this case. And we also have not Q. Not Q in this case, and the third row is false. So we have true, true, false. This right here is false. Okay, how about this? We have P or Q, and the third row, P or Q, is false. Well, we already know this entire thing will become false, but let's write down the rest, right? Not P is true, and not Q is true also. So we have false, true, true. And in this case, since there's even a single false, let's actually erase this. There's even a single instance of a false with all these AND operators, you get false. So therefore, this statement right here is a contradiction. So in this video, I showed you how to determine whether a statement is a tautology or a contradiction using truth tables, and if all the outputs, let's go ahead and erase this. So if all the outputs for a statement is true, always true, this is a tautology. Tautology. And maybe you could think of it as true starts with T, and tautology starts with T, so if something is always true, then something is a tautology, right? You can think of it as that. And a contradiction is the opposite, always false. So if a statement gives you false all the time, this is a contradiction. So if you have any questions, put it in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thanks for watching.